Hey, hello, Thor. Can you hear me?
I can hear you.
Hey, how are you?
I'm good this morning.
Very good. You've probably seen the news. Let me just share this. There is rumblings under Bárðarbunga. I guess you can see the headline here now. So, and there has been a swarm of earthquakes, and it's probably the strongest since the 2014 events there. And here the headlines read: Iceland's second largest volcano is preparing to erupt. And sparking fears of travel chaos in Europe. I um, I realized the earthquakes had a maximum of 5.1, so they're a little more serious. But how serious is that situation? What do you think, Thor?
It- how serious is it? Not that serious, to be perfectly honest.
I'm glad you say that because the headlines sound a little kind of intense.
Yeah, I mean, this activity is not necessarily unusual in any shape or form. Yes, we've had a slightly elevated seismic activity for a very brief period of time underneath Bárðarbunga.
Yeah.
And it's true. And I'll show you a little later on. I mean, it is very seismically active area. And I think these headlines are kind of overstating things a little bit. There are a number of things to think about in this context. What do you really mean by a volcano? Because
Well,
as you know, in Iceland, we have the sort of association of a central volcano and then fissures from that extend away from the central volcano, and these are sort of the two. Many people think, at least, that these are the sort of two fundamental structures of the volcanic activity in Iceland. Now, we also should note that there's a difference of interpretation in how these things are related.
mhm.
There are people that, especially geophysicists, but includes geologists, to be perfectly honest, that think that the central volcanoes are the center of activity on the volcanic system, and all the magma that comes up to the surface in this volcanic system come from a plumbing system underneath that central volcano.
Yes.
So the central volcano becomes the main feeder for the whole system, irrespective of its size, its nature, or whatever. And inherently in this model, the central volcano is something that evolves with time and
Mhm.
shows the maturity of the system. So they don't really think much about how that system was in the early stages, just looking at the state of the system today. And by that also means that the central volcano is the latest thing to evolve on these systems. And so you start with a fissure swarm, an extension, and things like that. And then activity concentrates on the central volcano, and that's why you build up the edifice there, and that becomes the main plumbing
Yeah.
system for the system. This would mean that the central volcano should be the youngest structure on the system.
Yes. This is an evolution that leads up to that
Yeah. I mean,
construction.
that's just inherited in the model.
Yes.
Now, the data that we have to date suggest that, and strongly suggest, that the central volcanoes actually are in fact the oldest structures on the systems. And the central volcanoes forms first, and then the fissure swarm develops. Now that just saying that in its own sense doesn't rule out the possibility that the central volcano and its plumbing can be the core to the system. But there are other evidence that suggests that actually all of the sort of volcanic systems in Iceland and all the central volcanoes are associated with multi-level magma storage systems within the crust.
Mhm.
And the extent of the storage system can be variable depending on the depth. And there's even some suggestion that maybe the deeper storages, they are actually more extensive. They actually have larger dimensions, especially along the axis of the volcanic system than the shallow ones. So the shallower ones would be feeding the central volcano, whereas the deeper one might be feeding the fissures out on the volcanic system.
I see. So
these are kind of things to think about, and so this is another model, and then you can even think of the third conceptual model where, maybe there is not that much of a link between what's happening at the central volcano and what's happening out in the fissure system. And then, we can't rule that out. I think that is unlikely, but we can't rule that out. Not with the current data set. What I think is the most likely is that, because we have some multiple evidence of this multi-level storage. We also have multiple evidence of the situation where it's very difficult to explain the fissure eruptions and then the magma composition of the fissure eruptions out on the fissure swarms as a consequence of a delivery from a single magma chamber at shallow depths underneath the central volcano. So it seems like more likely that whatever comes up on the fissure swarms is coming from a deeper level, and thus a deeper storage, whereas bulk of what comes up in the central volcano comes up from a shallower magma storage, which is right underneath the central volcano, and maybe you can think of that as on the top of this three-tiered system.
It's interesting you say that, because we see similar things in the Canaries on Tenerife. The felsic system in the center, like Teide, seems to be somewhat decoupled from the rift zones, and they can have eruptions quite independently, and they are deeper source.
Yeah.
Overlap between that zone and the rift zone, you may actually get some mixing between different compositions. And, I'm intrigued by this. But bringing us back to Bárðarbunga, there were these suite of earthquakes now, this swarm of earthquakes that happen to be on what people would like to think is the caldera margin of the central volcano, and not kind of the fissure swarm as we had the eruption in 2014. It was along the fissure. But there was also earthquakes under the volcano. So how do you think that links up?
Well, this is now you're looking at just a modern day activity, and you're not taking anything into account in terms of the geological history or whatever. And in this context, maybe I'll just share things. It's interesting to look at.
Go ahead.
Because people think, it's so unusual things happening at Bárðarbunga. But if you look at Iceland for the last year, let me see. Maybe I'll just do a full screen here.
Yeah, go ahead.
Is that okay? Do you see that?
I can see it, yes.
So this is just Iceland's seismicity for the last year, from February to February. If I can move that bar a bit.
You can see the central volcanoes.
But you see, here is Bárðarbunga.
Yeah.
See the arrow? Yeah. So this is Reykjanes Peninsula right here, and activity on that. And you can see there's quite a bit of seismic activity out on the Reykjanes Ridge as well.
I can see Eyjafjallajökull and Katla.
And here is Katla. Yeah. And here is Hofsjökull, and here is the area around Langjökull. So this is Prestahnjúkur volcanic system in that area. Here is Snæfellsnes, the recent seismic activity there. And you can see there's also quite a bit of activity in Grímsvötn. And yes, notably, there's been larger earthquakes at Bárðarbunga. The intensity of the seismic activity at Bárðarbunga is elevated compared to its status in the past, but it's not standing out in terms of number of earthquakes compared to other systems in Iceland.
Right.
If you look at a year basis, it does stand out on this plot. As you can see, the larger rings around here, and it has featured somewhat larger earthquakes, but also quite intense seismic activity at Askja and the neighborhood of Askja. And I can just run sort of quickly through this.
Go ahead, yes, please.
So this is just a close-up of the Reykjanes activity. So here is Sundjúkur. This is Fagradalsfjall. And notably, Fagradalsfjall has been quiet, but all of these earthquakes at Fagradalsfjall have been fairly deep, so 8, 9, 10 kilometers. Looks like they're actually at the roof of the largest magma storage. So suggesting a link between what's happening at Sundhnúkur, this accumulation in the shallow magma chamber, and the deeper reservoir. That's an interesting thing. But there's quite a bit of seismic activity over in Krýsuvík and Brennisteinsfjall area, fair bit on the South Iceland seismic zone. You go further, like we said, Katla, even Torfajökull. Hekla is relatively quiet, which is up here. If we look at southern part of Vatnajökull, there's been some seismic activity at Öræfajökull. There is interesting linear seismic activity over here, which is close to Hamarinn. I don't know what that means, but it's interesting. It's there. And then you have Grímsvötn and associated regions of Grímsvötn. And if we go to the northern part of Vatnajökull, so this is the linear seismic activity here we were looking at earlier, see Bárðarbunga, and we can see also a fair bit of seismic activity in Askja and in Herðubreiðardögl, close to Askja. And this has been, by the Cambridge group, been shown to link to magma accumulation in the subsurface plumbing system associated with the Askja volcanic system and Askja central volcano. It's actually really nice studies, and these are they've had a very dense seismic network around Askja for many years, and it's very interesting results that are coming out of that. And this is just North Iceland. Here is Krafla, for example.
Yeah, and you can see the fracture zones. It's really nice.
But you see the fracture zone quite nicely. Now, if we look a bit closer at, and this is actually, so this is a zoom in on the Bárðarbunga area. So basically what we're looking at is
this area there.
Yeah, this area right there. And you can see there's on these strong lineaments on either side here. I'm hard pressed to see this as ring fractures, but possibly. I find
you could also draw through the two parallel lines through there. So but maybe it is a ring fracture with a
I think that's a possibility. Bárðarbunga is right here. It's a possibility, but it is a strange kind of seismic.
Remind me, what is the depth of these?
The depth of these? Yeah, I'll show you that. Depth of these are in the range of 1 to 10 kilometers.
Well, 10 kilometers is too deep for the caldera basin. I think 1 kilometer would be reasonable. So not all of these earthquakes can be connected to ring fault.
No, and that clearly is something for more detailed study. But that's for the seismologists to do. Not my field of expertise, to be perfectly honest. But anyway, I think it's an interesting pattern. I mean, however you want to interpret it. But the other interesting thing is, look at the seismic activity over here.
Right.
This is all between 10 and 20. This is where the seismic swarm that eventually led to the Holuhraun eruption in 2014-15. This is when it began.
Yes. And
you can see it is a significant distance, see 3 kilometers here. So it's almost 7 kilometers between this activity and that activity. And this is probably meaning that there's magma coming up from depth there. This is the deeper feeding zone. Which is an interesting thing in the context. And then just down here you can see the depth plots. All of these deeper earthquakes are associated with this.
Mm-hmm. Do you think the earthquakes that could be potentially around the ring fault, do they signify magma movement, or what's your gut feeling? Because in theory, this could be just movement along the ring fractures from all sorts of processes.
Well, it's hard. I mean, I haven't really got into looking at where and how many GPS stations they have here. I think the GPS meter that they're using is actually based on the ice, or it may be on one of the nunataks, but they only have 1 or 2 GPS stations that are measuring. They claim there's a 25-meter inflation in this region of Bárðarbunga.
I read that as well.
I am a bit concerned about those kind of values based on, especially when we have such a few stations, and especially because if one of them is on ice, then you really need to take into account the ice volume changes, and I'm
Yes.
sure there have been some. So I don't know how realistic that is, but that, like I said, seismic activity. I don't think there's much magma movement associated. They claim that magma is accumulating beneath here. This is why they have the inflation. But I am not convinced. I mean, this could, as far as I'm concerned, this could be really movement along the tectonic movement along some faults. But they may also be correct. It may indeed be inflating, but that doesn't necessarily mean that it is preparing for a major or large-scale eruption.
No, it does not. Of course, this is the key issue. And even, I mean, the newspaper article I showed earlier, they reported that there is inflation. And I haven't seen the original data, but assuming this is correct, there has been inflation for a while now. Then that is still not an indication for a major eruption. We have ups and downs in Campi Flegrei and places like that, large calderas, and that doesn't always necessitate an eruption. There has been unrest there just last year, and obviously the eruption has not occurred. So although of course people are worried, but this is not a necessity.
Yeah, and I think the Nunatak GPS meter is actually outside of the caldera. And I think they're extrapolating from that into the caldera, and I think that is not a really good.
So there is uncertainty in these kind of values.
I think there's a lot of questions about exactly the quality of the data and the certainty of these measurements.
But so let's now.
But yeah, if we continue with Bárðarbunga, just to finish. So
absolutely,
I mean, there's no question about the seismic activity. Now, is this as people have been saying, some people are saying the most powerful volcano in Iceland. Others are talking about it to be the second largest or even the largest volcano in Iceland.
You say that, yeah.
and these are the headlines. I mean, we're not making this up. And I think it's really interesting to try to sort of look at it. What underpins those statements? Why are people saying this? And if you look at the seismic activity, we can all agree that there's been quite a bit of seismic activity, and then even quite intense seismic activity at Bárðarbunga. And if you want to look at just from that point of view, well, maybe it is one of the more active centers in Iceland in regards of earthquakes.
Mm-hmm.
And whether it is the second one or the first one or whatever, I'm not going to be a judge of that, but that absolutely is true when you just think of the seismic activity. Now, if you think of Bárðarbunga in terms of its sheer size of the volcano,
mm-hmm.
and we published these results in 2008, so they're not. This is nothing new. Bárðarbunga is one of the smaller central volcanoes in Iceland.
But you read the headline, it's the second largest.
I mean, by far the largest central volcano in Iceland is Hofsjökull.
Okay. Which is probably not so well known overall, actually.
No, and number 2 is Katla.
Yes.
And number 3 is Öræfi. And then the rest of them come somewhere behind. And as it turns out, when you calculate the volume of Bárðarbunga, it's actually smaller, slightly smaller than the volume of Grímsvötn.
Mm-hmm. Okay.
So I mean, it's a from that point of view, this is a total misconception.
Yes, I think so too. I think it was overstated there, and this is why I felt it's important to clear this up a little bit.
And the other way people have been thinking about Bárðarbunga, I'm just going to scroll back here a little bit. Thinking about Bárðarbunga is that we've had eruptions here on what we call the Veiðivatn fissure swarm. And we also had eruptions here on what is called the Dyngjuháls fissure swarm, which is north of Bárðarbunga. And you can see in both these regions, there's hardly any seismic activity.
Hmm.
We've had some big eruptions on those fissure swarms, and people have linked those fissure swarms to the Bárðarbunga central volcano. So they're associated with the Bárðarbunga central volcano, but it depends on what model you think of, whether you think all the magma is coming up underneath Bárðarbunga, then be delivered out in the fissure systems or fissure swarms, or whether you think of it as a multi-tiered magma storage system where you can have fissure eruptions fed independently of the
Yeah.
central volcano. So stating that, using that as an argument for the size and the magnitude of the system of Bárðarbunga central volcano itself is a bit misconception as well. You're taking a leap there, and you're assuming that one model is better than the other without any evidence at all. Actually, the evidence point to the contrary, if anything. I mean, if you were looking at the evidence with a sort of a critical eye, then you would say, like, well, there's no evidence of activity at Bárðarbunga during the Holocene. We don't have any clear-cut evidence of Bárðarbunga having erupted in the last 15,000 years. Well, while the fissure zones have been quite active, and if the magma storage for those are semi-independent of each other, then the fissure swarms, they've been active, but the central volcano hasn't been doing anything. And then you can't say the central volcano is the most intense volcano or powerful volcano in Iceland, because it hasn't. We don't know whether it has erupted in the last 15,000 years.
There was rumors about subglacial eruption in the caldera during the 2014-15 events, but I never saw that really confirmed. Do you know much about that?
We don't know yet whether that was an eruption or not, or whether it was just melting of the ice. But yeah, there was down in this region here of the volcano, there was some melting of ice, and a lot of people are convinced that actually was a little bit of a basaltic eruption, and that's very possible. I would raise enormous concerns relating Holuhraun magma to any magmatic activity underneath Bárðarbunga. I think that is based on what I've done and my analysis, that is totally wrong. And there are, the main reason for it is that we did have a seismic gap also in 2014. There was no link between the seismic activity, direct link between the seismic activity in Bárðarbunga and the seismic activity over here that actually drove the north trending seismic swarm that ended up where the Holuhraun was. And if magma is moving from here to there and then going north, so it was actually based on what they did in seismic was in 2014, they would have gone this way, and then taking this turn, which is about well over 100 degrees turn, and then moved northwards. And the magma is supposed to take that turn here without creating any seismic activity, but creating seismic activity when it's going here and seismic activity when it's coming here. So where you would assume the strain rate is the highest, because that's where you take it, if you're thinking of a dike, because you're coming down like that and taking a turn like this, the strain rate and the G forces and everything is going to be highest in the turn. And no seismic activity.
And there is nothing. But how do you explain that the caldera had subsidence at the same time as the eruption was going on?
I question the degree of subsidence. I think that's overestimated.
I see. On what basis? Help me out.
Because the meter was on ice. We don't know how much melting of water took place there. And if you melt ice, you reduce its volume by 10%. So that would have to be taken into account. So I agree there was substance there, and that suggests that some kind of hydraulic relationship between whatever happened in the subsurface underneath the seismic swarm that led to the Holuhraun fissure and what was happening on the Bárðarbunga. And of course, again, this is kind of how you explain that depends on your views, and then there's a lot of assumptions and interpretation that would have to go into any kind of a explanation for that. Doesn't matter whether that is a view that I present or someone else. It's all based on interpretation. And the way I see it is that because we see this deeper seismic activity well before 2014, actually 10 years before 2014. So I think the magma was accumulating, in the say lower to middle crust somewhere for that period of time, and it may have formed actually a sill-like body that may have extended, some distance here to the north, and also may have had some dimensions, towards Bárðarbunga. Now, if you think of that, people would like to think of magma intrusion just as a complete pure liquid, but it never is. So it's always going to be a kind of liquid crystal mixture, right? Kind of a mushy kind of a zone. And so you have crystals and liquid in between the crystals. And if you have that zone, which is like a sill-like body in here, which is connected from this area all the way to the north, then it's a possibility when you start to extract the liquid part of the melt from some part of that sill-like body, let's say the northern end of it, and that would have a chain reaction through all the melt horizons within that sill-like body, and you readjust the liquid portion. So it actually, you extract it out here, and then it moves northwards, and you keep extracting here. Then this area down here in the south will subside.
Interesting.
That's one possible explanation, and I think that is something to think about and see. So it's a conceptual kind of model, and the way I think of these things. And okay, I got a conceptual model. Let's sit down and think about what evidence is out there already that actually supports this. What evidence are out there that actually contradict it? And can we just work out, and then you can refine it as you go along, because I'm sure, even a simplistic view like this is never going to be explaining everything fully. So you need to, but it helps you actually figure out what you need to look at in order to, kind of come up with a more reasonable model than we have right now for the
Yeah, but
2014,
to be frank with you, I mean, that's not how human minds work. We want a single model, and ideally a simple one, and then we want to stick with that forever and not go back and question it and modify it. So
yeah, I know. And another thing in this, and so if I share here again, let me just see if I can can I escape here somewhere? Oh, stop sharing. Let's just do this.
yes, you can stop.
And then I'll do that again because I want to show you this here. I talk a little bit about eruptions that have been linked to Bárðarbunga.
Yes, I'm interested because, of course, the big question is if there is an eruption, how will it actually look like, and what kind of eruption it is. So
Yeah.
it's good to look at the record.
So this is just chemistry and glass chemistry and probably. So if you look at these plots, so this yellow line actually outlines the compositional field of a series of central volcanoes, which include volcanic systems, which include the Veiðivatn Bárðarbunga volcanic system, the Krafla volcanic system, and the Askja volcanic system. So if we look at all the data that we can, glass data, this is of course glass analysis, melt compositions, in other words, which in my view is the only thing we should use. Whole rockets can be misleading, at least when you do in compositional fields like this, because it can be affected by the crystal content of the magmas. But so Askja, Bárðarbunga Veiðivötn system and Krafla fall within this yellow line. And the red dotted line, that's actually Askja volcanic system.
Mm-hmm.
The black broken line, that's Krafla. And then we get to Veiðivötn Bárðarbunga. And when I initially did this, I used just blindly all of the data that was available for Bárðarbunga, and then it looked like this. And extended way back here with some primitive composition. Just using data from volcanic formations that people had without necessarily good underpinning of data or arguments, but I just attached them because of where they were located to the Bárðarbunga system or because of their composition to the Bárðarbunga volcanic system. And so that's, but if you look at the data more carefully and you start analyzing it in greater detail, then you realize that what is erupted on the Veiðivötn fissure zone, those are eruptions that we know of, like Veiðivötn 1477, Veiðivötn 1717, and the settlement layer, to name a few. And of course, in this also is part of the Dyngjuhál system. And you get a composition field which is shown by this gray line here, indicated as Veiðivötn fissure zone right there.
Right.
If you look at the glass composition for eruptions at Dyngjussandur, i.e. Holarhraun, the Holarhraun 2014-15, Holarhraun 1867, and Holarhraun 1897. They all fall here at a more evolved. They clearly fall on the same trend. And you can see that also here. So this is Dyngjussandur here, and this is Veiðivötn fissure zone. And the red field is Veiðivötn 1477, and this data here, the blue ones, are actually data from Veiðivötn 1477 tephra layer in a lake called in Heiðavatn in eastern Iceland, just as an example. So it shows kind of what all fits together. But the interesting thing is and when you start thinking about these things, okay, if these were linked to a single magma storage zone underneath Bárðarbunga, and now we're more or less talking about historic eruptions. So we know where these things took place. But why are they so compositionally different?
Yes.
Why is the Veiðivötn stuff more primitive compared to what comes up in Dyngjussandur, if those things are indeed linked to the same magma storage body? The other interpretation is that these might be two different magma pockets at different levels within the crust, which are erupting independently of each other.
Some of these primitive things might be even deeper, might be from just the lower crust or even the boundary.
So clearly we have work to do.
Yes, no, I see that. And this is not really resolved. And attractive models that get published, they're not always right. So I see that as well. So it's good to question all of this. And and
also, just to add to it, a lot of the data in here, which is on, shows the spread, is also data from tephra layers that people have sampled in either soil profiles or even lake cores, well away from the eruptive centers. And people don't know, you see the tephra layer there, it was formed by an eruption, but you don't know exactly where the source is. And you can't figure that out unless you map out that tephra layer and trace it back to its source. If you do an isopac map of the thickness of the tephra layer, it will be thickening towards the source, and you should be able to find the source just using, but none of that has been done for those tephra layers.
So they're basically they are assigned because of their chemistry.
They're assigned to Bárðarbunga because of their chemistry.
Which,
now,
It's tricky, yeah.
And many people assign them to the Bárðarbunga central volcano because they have a similar chemistry to the Veiðivet 1477 tephra.
I see.
And of course, it's possible that some of these tephra layers indeed came from Bárðarbunga, but it's also possible that some of them came from eruptions out on the fissure swarm that have nothing to do with the Bárðarbunga. It's also possible that all of them came from eruptions out on the fissure swarm and none of them came from Bárðarbunga. And before we start to talk about how powerful or big or whatever Bárðarbunga central volcano is in terms of volcanic eruptions, we need to know this. We need to have this information at hand. How many eruptions came from Bárðarbunga in the last 15,000 years? Now I'm talking about the Bárðarbunga central volcano. I fully agree. Most of those are probably from the Veiðivet Bárðarbunga volcanic system. But we don't know whether they came from eruptions out on the fissure swarms or whether they came from eruptions within the central volcano. And while we don't know that, we cannot be making statements like we have been seen in the press, because they are not backed up by any data at all.
Yes, I see your concerns, and there's a lot of uncertainties. But yeah, no, it doesn't make for a good headline when you put it like this, Thor. You know, you wouldn't sell a lot of newspapers here. So
No, but no, this is also dangerous from the point of view we're sending out, signals.
It's about the message,
something
absolutely.
That is dangerous when we don't know. And if you start thinking about assessing risks and preparedness and how people's anticipation towards these things, you're sending basically misinformation there. And part of the story that they say could be possibly right, but it also could be very, very wrong.
It could be, and this is a headline. This is exactly the issue. But let me bring the discussion briefly to kind of a wrap up. Do I sense it right that most likely, if there's a Bárðarbunga event in the coming years or so, it would be along the fissure swarm and not necessarily in the central volcano? Is that reasonable from your perspective, or are we not at all sure how it could actually pan out?
I think that is more likely because, however you look at the historic activity, it's all out on the fissure swarm. None of it is in the central volcano. Not that at least we can confirm it. There have been some eruptions under the ice, but they could also, the fissure swarms extend under the ice, so they could be on a fissure under the ice and outside of the central volcano. And so I think that is probably more likely to happen. I think there's also a possibility that we will have an eruption at Bárðarbunga, but I don't think that necessarily is going to be a big eruption. We have no evidence at hand that shows that Bárðarbunga has produced a big explosive eruption. The Bárðarbunga central volcano, we don't have any. It's a possibility it may have done it in the past because we haven't, we don't have a full record of everything. We haven't studied all of the Bárðarbunga, and most of it is actually under ice still. So we see very little of it, and it is a difficult one to assess. But that does not give us a free range of just speaking irresponsibly about, some big eruptions that are going to happen there because of blah, 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 blah. I'm sorry.
I am with you. It's I come back to this example from Tenerife because all the historical eruptions were relatively small eruptions on the rift zone. Some of the lavas went down to the coast and did cause some damage, sure, but it's not big explosion eruptions or things like that. So these systems actually, we have to be a little careful. It's easy to look at the center and be a little intimidated.
Yeah, and if there's an eruption at Bárðarbunga central volcano, it's most likely going to be a relatively small one. Maybe, because, and the reason why I say that is because if we're going to have an eruption at the Bárðarbunga, it's probably coming from a relatively shallow magma storage. And the shallower the magma storage is, the less of a overpressure you build up in the storage zone because the overburden is just that much less. The lithostatic pressure is less, and the roof is weaker.
Mm-hmm.
In other words, prior to the event, the roof will fail much earlier in the pressurization of the magma body, and So as a result, you have lower overpressure, i.e. less intense eruption, unless you actually go into a silicic magma. And then we're talking about a totally different story.
Yeah, let's hold our horses. I think exactly so.
Exactly.
Just as a concluding remark, Bárðarbunga is not in a very densely populated area. There isn't a lot of massive infrastructure in that area either. What's the risk for populations in case we have a small eruption like 2014, or in fact in the central volcano area?
It will have relatively, basically no impact on infrastructure, except it may potentially cause some disruption to flow of water in rivers like Tungna, where we have some other hydroelectric power plants located on. I think overall the risk associated with potential eruption at the Bárðarbunga central volcano is relatively low, even if it creates a little bit of a jökulhlaup and some water coming down. I think that would be still a low impact, relatively speaking. Now, if we have a eruption out on the Veiðivatn fissure swarm, I mean, even eruption on the Dyngjahóll fissure swarm to the north is not really a big concern, because that would just be another lava flow eruption in an area which there's no infrastructure, there is no population centers or anything. But if it happens on the Veiðivatn fissure swarm, then depending on exactly where the eruption is, depending on how intense and how big it becomes, not necessarily the same thing, so how powerful it is and how much lava it will erupt, it can potentially have significant impact on very important infrastructure in Iceland, which are the hydroelectric power plants, which are dotted along the river of Tungna within the Veiðivatn fissure swarm, and Þjórsá, which is downstream from the Veiðivatn fissure swarm. So the lava flows that were produced, they will most likely go into these river channels, the river channel of Tungna and Þjórsá. They could dam up the rivers, change their course, so actually the power plants don't get any water anymore. And this is the main power generating region in Iceland. So that would be a huge concern, and much bigger concern than a potential eruption in Bárðarbunga.
Yes, I see that. And so the claims by this newspaper about air traffic problems like we saw with Eyjafjallajökull in 2010, I think that is overstated, but the local problems that you described for potential secondary effects like damming up rivers and then causing issues down the line for power plants, that I think is the things we need to worry about, maybe even more than these
yes,
kind of...
yes, air traffic, I don't think we really need to worry about, because both the regulations have changed. Eyjafjallajökull was its ash generation was overstated. There wasn't that much ash in the atmosphere, and we can talk about that at some other instant. But regulations have changed also a lot since 2010, and so I don't think subglacial eruption in the Bárðarbunga central volcano would cause any more disruption to air traffic than the Greenswell 2011 did.
Good. Thanks for clarifying that, Thor. So I think we have now cleared up a few things, and I am very grateful that you took the time. There was a lot of detail I had no real idea about, so thank you for sharing that. The overall assessment, I can sympathize with you fully. I think the news are overstated, and we can all have a quiet Sunday afternoon, because today's Sunday. So, and have a large piece of cake and enjoy the day.
I definitely will. I will at least have another cup of coffee. And
yes, that sounds great.
It's very important for people to keep in mind is that impact is not necessarily always have a linear correlation with size or intensity. And the current activity at the Reykjanes Peninsula demonstrates that very clearly. It demonstrates very clearly how important eruption location is.
Yes.
much more so than the size and the other thing.
Yes, very quick word since you mentioned it. Very quick word. I read on the Met Office webpage that if they look at their inflation data and they project it, then they are predicting or forecasting that towards end of January there could be another eruption coming. It's probably not unrealistic that we're facing more little eruptions there.
Oh, no, I think that is possible. It looks like this inflation period is slightly slower than the last one, so it could maybe drag on into somewhat into February. But I think they're absolutely right. Right around the change from January to February, I think we need to start thinking about or worry about another eruption on the Reykjanes Peninsula.
Here we go. I think that's the bigger concern, actually. Bárðarbunga is not a prime target right now. I'm not getting ready for Bárðarbunga, but Thor is back on the menu, I think. So, okay, good. Then let's wrap this up. Thank you very much, and I'll talk to you again very soon. And all the very best, Thor.
Okay, thank you.
Hello, bye bye.
Bye bye.